We're going to continue where we left off with collision theory. So just to remind you, we saw in the last lesson that reactants have to actually collide with each other, so physically collide, in order to react. And when they collide, they need to collide with a significant amount of energy. If they collide with not a lot of energy, they'll just bounce off each other. If they collide with enough energy, then they'll actually react, which is what you want. And we saw that increasing the surface area and increasing the concentration and increasing the pressure all resulted in more frequent collisions, which meant the reaction was faster. We didn't, however, look at what we could do to increase the amount of energy that we are going to look at today. So the next thing we're going to look at, we have seen this already, is that temperature will affect the rate of a reaction. Okay, we've seen on previous graphs that we've looked at that if you increase the temperature, you increase the rate of the reaction. But today we need to look specifically at why that is the case. So one reason relates to what we've already been talking about, okay? So we see that if the reactants collide more frequently, the rate will be faster. If you increase the temperature, the particles move more, okay? So they move quicker. And if they're moving more quickly, they are more likely to collide, so you're going to get more frequent collisions. So it will be the equivalent of me telling you all to stand up and run around N32. Okay, if you were walking around N32, you should be able to avoid each other. If you're all running as fast as you can, you are going to collide. So increase the temperature, the particles will move a lot quicker. If they're moving quicker, they are more likely to collide. And remember, anything that gives you more frequent collisions is going to give you a quicker rate of reaction. Okay, but when we're talking about temperature, there's another reason that increasing the temperature will increase the rate of the reaction. And this relates to the second point here, the amount of energy that the particles have. So we've got a new, I'm pretty sure this will be new to you, a new phrase that we need to talk about called activation energy, which I don't think you will have come across before. So activation energy is the minimum amount of energy reactants need to actually react. So if I go back to my example of reaction over here, I've got hydrogen and oxygen. If I want my hydrogen molecule and my oxygen molecule to react, there's a certain amount of energy that they're both required to have in order for this reaction to be successful. And the amount of energy they need is going to vary from reaction to reaction, but there is a certain amount of energy that they are required to have so that they collide with enough force to actually drive the reaction forward. And we call this amount of energy the activation energy. Okay, so it's just the minimum amount of energy that the particles have to have in order to react. And if you increase the temperature, so we've already said the particles are moving quicker, but as well, when you increase the temperature, okay, you are increasing the energy of the particles themselves, which means more particles are going to have the required activation energy. So you're giving the particles themselves more energy, which means more particles have required activation energy. Particles have required activation energy. So anytime you are asked about temperature and why increasing the temperature increases the rate of the reaction, you have to give me two reasons. You have to say, if you increase the temperature, the particles are moving quicker, so are more likely to collide, you get more frequent collisions. But You're also giving the particles themselves more energy. And if they've got more energy, then more of them are going to have the required activation energy. That means when they're actually colliding, more of those collisions are going to be successful. Less of those collisions are just going to result in them bouncing off each other. And you're going to have more successful collisions where they're colliding with enough energy to actually react. And in your booklet, I just want to draw your attention to it. I've gone through. This is on page 28. Okay, so I've written this out for you here. All right. But I just want to draw your attention to how you would write this in an exam. So you ignore the rest of the answer for now. Okay. But when you're talking about increasing temperature, okay, you have to tell me that the particles move faster and collide more frequently. Okay, that's mark 1. You also need to say that a higher temperature means that more particles have the activation energy, so more collision results in a reaction. So in your booklets there at the bottom of page 28, learn those 2 sentences. We're going to be doing exam questions later, and you will see on the mark scheme that these are the sentences that are required when you're talking about temperature. Okay, there's one other thing that we can do to increase the rate of the reaction, and again, this is something that you will probably have you've definitely come across before, and that's just adding a catalyst. So we've come across that word catalyst a couple of times because when we looked at enzymes, we saw that enzymes were catalysts, and catalysts are just, in general, you can define them as just substances that increase the rate of a reaction. Increase the rate of a reaction. And catalysts are never used up during a reaction. So they increase the rate and they are not used up. And that's all we've ever learned about catalysts. But now you need to know how catalysts actually increase the rate of reaction. What is it they do that speeds up the rate of a reaction? And it relates to our second point. Again, it relates to this, the amount of energy that the particles have. And what catalysts actually do, I'm going to draw you a little diagram that we're going to see a lot in our next topic. I'm just going to draw you out a little sketch. And it's called an energy profile diagram. And on my y-axis, I just have energy. We always draw these as general sketches and we never actually put numbers on the y-axis or numbers on the x-axis, okay? But what it shows me is I'm starting off here, just say my reactants have this amount of energy. In order to react and become products, they need a certain amount of energy, and then they can go and they can become products. And I'll talk way more about these diagrams in the next topic, okay? But the energy that they need to become products, this energy here, this is what we call the activation energy. This is the energy that they need to have in order to be able to collide successfully and become products. And we call it the activation energy. And what a catalyst will do is a catalyst will lower the activation energy, So it's equivalent to when we talk about grades at GCSE. So just say you've all recently done a test for me. And I could say you need 90% or above to have a grade 9. So 90% is the required mark to have a grade 9. But then just say I decided to lower that grade boundary and said, instead of needing 90%, you now only need 80% to have a 9. Okay, the number of 9 grades in the class would massively increase if I lowered the requirement for getting a 9. And that's exactly what a catalyst does. Okay, initially you might have needed 500 joules of energy in order to be able to react. But what a catalyst is going to come along and do is a catalyst will lower the amount of activation energy required. So if you've got a catalyst in there, instead of needing 500 joules of energy, now you only need 250 joules of energy. Because the catalyst is lowering that standard and lowering that requirement, you've got more particles in your reaction flask that have the necessary energy and that are now able to react. Okay, so in terms of how you would phrase that in an exam, you don't need to draw out diagrams that I have included for you here. You will do it as such. Okay, this is worked example 1 on page 29. Okay, you will say that catalysts increase the rate of reaction. We already knew that. and they do that by lowering the activation energy. This means that more particles have the energy required to react. Okay, so they would be your 3 important points when you're talking about the effect of a catalyst on a reaction. Okay, also important to note that catalysts are not used up during the reaction. You will end with the exact same amount of catalyst that you started with. And also another really important point, you're not going to get more product by using a catalyst. Okay, you're going to get the same amount of product as if you didn't use a catalyst, but you'll get that product a lot quicker. So just say you're doing a reaction and you do it without a catalyst and it takes you 10 minutes. Scroll something up here. It takes you 10 minutes to produce 100 grams of your product. Okay, you do that with a catalyst and it might only take you 2 minutes to produce 100 grams of your product. So using the catalyst means it's taking less time, but you're not increasing the amount of product. Okay, you're still getting the same amount. It's not going to affect the amount of product. In the next video, I'm going to go to your booklet. I'm going to tell you what questions I want you to do. So tune into the next video to see what work I actually want you to do.